Alrighty, science fans. This is the one they don't want you to see, okay? Of all of the reels I've ever done, this one is like a culmination of all of them. The speed of light radiating from the sun. I went over the one where we used a little bulb as the sun, so I'm using that bulb again, but with a 2-scale solar system, okay? Now, we're going to start from the very, very beginning here. Those of you that don't know my shenanigans, I've always been a big believer of following hunches, and it was so obvious. The reason it's so obvious is by the sun that's in the sky. I find that that's enough, all right? I really do. No more is needed. I can't remember when it was. I'm always looking at numbers because I know something is out. Was it 2 years ago? I don't know when. I had these numbers up just looking at stuff in general, right? Nothing specific, just looking at numbers, just working things out. And I saw these two side by side. That's the diameter of the sun, and that's the speed of light. I thought, hang on a minute, you divide the diameter of the sun by the speed of light, 1,390,000 divided by 299,792, that's kilometers per second, and we get 4.6. Bang! Alarm bells. How could it take the sun, right, 4.6 seconds to radiate light? Its own light, the distance of its own diameter. It's like bathing in dirty water, right? It's a physical impossibility. It defies common sense. It defies logic. It defies everything, right? So then I worked it out, went over. This went on for a couple of months. I was screaming the house down. 4.6 seconds, the diameter of the sun, 1,390,000 kilometers. 1 second, 2 seconds, 3 seconds, 4 seconds, and a 0.6. How is it even possible for anything, right, to radiate light 4.6 seconds per its diameter? It must be physically impossible, right? But no, some people are going, yeah, so it does. What? No, it doesn't. 3 sun diameters. 1, 2, 3. 4.6 seconds plus 4.6 seconds is 9.2 plus another 4.6 is 13.8 seconds. You honestly think it takes the sun 13.8 seconds to radiate its light the distance of 3 of its diameters? Think about it. It's insane, right? It's insane. It's illogical. It is not so. So from here, it's been one thing after another. It's a case of proving what you already know, right? Now, the things that I've worked out, everything from here onwards is to do with diameter. It's to do with the sun's diameter, right? Now, there are 150 million alleged kilometers, 150 million between the sun and planet Earth. The alleged diameter of the sun is 1,390,000 kilometers. If we divide the distance, 150 million kilometers, by the diameter of the sun, 1,390 kilometers, we get 107.9. Alexa, what's 150 million divided by 1,390,000?
150 million divided by 1,390,000 is approximately 107.9137.
We're going to call it 108, right? There are 108 suns in between us and the sun. 108 suns. Everything up from here forward, right, it's been worked out on that calculation. It's the benchmark, right? 108 suns, diameters of the sun between us and the sun. So what we did, which I did the other day, right, now May, I've gone a little bit extra. Don't fall phone, please. Right, there we go. So, now what I need you to see up there as well. Right, that should just about be it. In the middle is the sun. It's a little bulb, okay? The bulb I used the other day. It's got a diameter, we're calling it 5 millimeters, right? 5 millimeters. Let's go to Earth first so it makes sense. So what I wanted to do was a 2-scale diagram of the solar system, at least of these 4, and I've got Jupiter just to show that perspective, right? A working diagram with a sun and a 2-scale the orbits of the planets, the first few planets. So the sun in the middle, tiny bulb, and planet Earth. It's 150 million kilometers. There is 108 sun diameters. So what I've done is 5 millimeters times 108 diameters. Alexa, what's 5 millimeters multiplied by 108?
5 millimeters times 108 is 54 centimeters.
54 centimeters. So the correct scale with a sun that's 5 millimeters, planet Earth would be here, at 54 centimeters. Now, planet Earth is big there, but it's big for a reason. It's big so that we can see where it's at. So the next question is, how big would planet Earth be? No, let's finish off here first. Right. So what I did, I'll do Earth first again. It's 150 million kilometers between the sun and Earth. That is 108 sun diameters. That's 54 centimeters. 108 sun diameters of 5 millimeters is 54 centimeters. So that's 54 centimeters from that sun to there. It is 100% to scale. So we start from Mercury, 69 million kilometers away. Sun diameters, so we divide. Alexa, what's 69 million divided by 1,390,000?
69 million divided by 1,390,000 is approximately 49.6403.
49, so that's 49 sun diameters. 49 times 5 millimeters. Alexa, what's 5 millimeters times 49?
5 millimeters times 49 is 0.245 meters.
Or 24.5 centimeters. Mercury, 24.5 centimeters to scale, right? If the sun was 5 millimeters, if its diameter was 5 mil, that is where Mercury's orbit is. Venus was next, 107 million kilometers. I'm not going to keep asking Alexa. This is how I worked it out. You can recheck it yourselves. Venus, 107 million kilometers. That is 76 sun diameters. We divide 150 million by, we divide the 107 million by the sun's diameter. We get 76 of them. That's 38 centimeters. Earth, we know, 54. Then Mars, 212 million kilometers. We divide that 212 by 1,390,000 and you'll get 152. 152 times 5 millimeters is 76 centimeters. And finally, Jupiter is 753 million kilometers away. If we divide, last one, Alexa, what's 753 million divided by 1,390,000?
753 million divided by 1,390,000 is approximately 541.7266.
Okay, we want millimeters. Alexa, what's 541 multiplied by 5 millimeters?
541 times 5 millimeters is 2.705 meters.
2.7 meters, and that line you'll find is 2.7 meters, and it's Jupiter's orbit around a 5 millimeter sun. Right? Now, size of the planet, well, I'm not going to do the size of the planets, we'll do the size of planet Earth, because it's the only one that really, it's not the only one that really matters, but we live on it. So, what was that? Yeah. Okay. So here we go. So if the sun is 5 millimeters, if its diameter is 5 millimeters, where does that leave planet Earth? What are we looking at down there? Right. If we divide the sun's diameter by Earth's diameter, we get 109. Okay, Alexa, what's 1,390,000 divided by 12,742?
1,390,000 divided by 12,700 is approximately 109.4488.
So there are 109 Earths, the diameters, inside the sun's diameter. So what I've done is we divide the sun's diameter by 109 Earths, right? And we get 0.045 of a millimeter. A micrometer is 1,000 millimeters, right? So, no, it's a 1,000th of a millimeter. So there are 1,000 micrometers in a millimeter, right? 1,000 of them. Earth is 45 of those micrometers. So you've got 1,000 micrometers in a millimeter, and Earth is 45 of them. Tiny, okay? So when we're looking down there, planet Earth, what we're looking at is really 45, right? It's 45 of 1,000 micrometers that are in a millimeter, right? So in a millimeter, well, I was going to say how many Earths can you fit? It'd be 109, wouldn't it? No, that's 109 in 5 millimeters. So we're looking at 21, 22 Earths, right? Fit in 1 millimeter. And then it was just a case of, and Jupiter's there as well, right? So Jupiter, because Jupiter's the biggest planet, so it's good to put it into perspective. Jupiter, if we divide the sun's diameter by Jupiter's diameter, because Jupiter is 10 times, 11 times as big as us. So it's 10%, right? It's 9.94. Alexa, what's 1,390,000 divided by 139,822?
1,390,000 divided by 139,822 is approximately 9.9412.
Right, so there's basically 10 Jupiter diameters in the sun, just under. And there are so we're at 12,000, so that fits into 139, like 13 times, right? So it's bigger than us by, 10, 11 times? 11, 13, 12, 20, yeah. 11, 12 point something times. That's Jupiter. So now we've got the 4.6 seconds that it takes the sun to radiate light the distance of its own diameter. All right? So what we would expect to see is the sun taking, this is a working to scale diagram of the first 4 planets in our solar system with the sun in the middle. Now let's get one thing straight right here. This is no different than if I brought this planet down, right, and said, right, we want to see how long it takes an aeroplane to go from the UK, we see this, can't we, from the UK to Mallorca, all right? It takes, on average, 2 hours. So this is brought right down to this size, because believe it or not, planet Earth is bigger than this, okay? It's brought down to size, and if we watched a plane, somebody explained to us an aeroplane flying to Mallorca, we'd be sat here for 2 hours. All right, it's over the channel, it's just started to go over France. We'd watch it take 2 hours, right? Because the flight time is going to be to scale. It doesn't matter how big or how small this goes, the flight time is going to remain the same. So what we have is a sun whose speed of light will remain exactly the same. So what that says is it's going to take 8 minutes and 20 seconds for the light to reach here, okay? And it's going to take 3 minutes 20 to get to Mercury. Venus is going to take 6 minutes. Don't know if you can see that up there. I did those just to, well, you can, about, right? So to Mercury takes 3 minutes 20, then Venus takes another 240, that's 6 minutes, and then to Earth another 220, that makes it 8 minutes 20. To Mars plus another 440, that's 13 minutes. To Jupiter another half an hour, 43 minutes. To Saturn another 40 minutes, that makes it 83 minutes, an hour 23. To Uranus another 77 minutes, that makes it 160. 2 hours 40. To Neptune another hour and a half, that makes it 250 minutes, 4 hours 10. And to Pluto another 80 minutes, another hour 20. That's 330 minutes, 5 hours and a half. 5 hours and a half for the sun to radiate its light to its furthest planet. It's ridiculous, honestly. I've always thought it was ridiculous, but people don't reckon it is, because they reckon the speed of light is at this snail trickle pace, right? 299,792 kilometers per second, when it is in fact absolute. It cannot be timed, it cannot be measured. If the sun was to turn on right now, this is a 2 scale with a 5mm sun. We've brought the sun down, we've condensed it from 1,390,000 kilometers to 5mm. That is still the sun. So what happens? Is it going to take 8 minutes and 20 seconds to reach Earth? Of course it's not going to take 8 minutes and 20 seconds to reach Earth. Is it? We turn the light on. In fact, you won't even, from where you are, you're on Jupiter's orbit line, right? You wouldn't see this for 43 minutes. So you'd be looking, going, what are we looking at? Because it's going to take 3 minutes to get to Mercury, right? And then Venus, 6 minutes, and then Earth 8 minutes 20, and then Mars 13 minutes. It's ridiculous, because when we do this, that happens. That is absolute light. Now, make no mistake about this, right? That is a sun down there. It's only 5 millimeters in diameter, but it's a sun. So how on earth are people believing? How on earth are they saying that it's been worked out that the sun would take 3 minutes 20 to get to Mercury, right? How is it even possible? And then what, another 2:40 to get to Venus, and another 2:20, which makes it 8 minutes and 20 seconds for the light to reach Earth. It is an absurdity, which is why we're here, because we're absurdity busters. The sun's light is absolute. It could be easy. People could now be saying, yeah, but you've condensed all of that millions of kilometers, hundreds of millions of kilometers, all into this little tiny space, and you're expecting, what are we expecting? It's light. It's light. Are you telling me now that if we brought that sun down here, it wouldn't do this? If it was that tiny size? What on earth are people thinking? We condense the sun down and bring it down to 5 millimeters, like that bulb, but what, it's got no legs? It's impossible. It makes no sense. It is impossible. It's ridiculous, right? It's absolute. Light is light. If we put a candle next to something that radiates its light like this, the candle kicks its ass, doesn't it? Because if we lit a candle here in a little box and we lifted the lid of the box up or just took the box away, even a little candle, if you're stood over by this door, it's going to throw a shadow on the door immediately, right? Now this is a 2-scale diagram of the first 4 planets in the solar system with their respective orbit distances from the sun, with a sun that is at 5 millimeters, right, in diameter. So why on earth are we getting this boom? If I've used a bulb, so we are saying that, oh yeah, no, if we brought the sun down because of whatever, it wouldn't be as powerful as a bulb. No, in fact, it's going to radiate its light so slowly, it's impossible, right? Now, I do not know what other evidence is needed, right? This is it right here. Light is absolute. It will radiate as far as it can go, as far as anybody can see it looking at light. If you see it, right, it's reached you immediately. Doesn't matter how far it is. If it's powerful enough for us to see in the night sky, it's because it is there in the flesh. There is no travel time. It's illogical. The light radiating from the sun cannot be measured. It cannot be timed. And that is why there is no calculation. Like I have shown every single working out I've done, because that's how you do things like this. You don't just make stuff up and make claims. Roma, 1676, what was he doing? Even thinking about the speed of light from the sun. It's ridiculous. The whole thing is ridiculous. Just for fun. I did the other planets. Oh, Neptune's fallen off. Saturn. So we've got Saturn, another 40 minutes. Oh, we went down to the end, didn't we? 83 minutes plus 77 for Uranus, 160 minutes. It's 2 hours 40. All the way down to Pluto, 5.5 hours. So there you go. Saturn, 83 minutes. Uranus, 102 hours 40, 160 minutes. And then we've got Neptune, it's fallen off the block, which was 4 hours 10. And then finally Pluto was 5.5 hours. So with this 2-scale solar system, if that sun did what it does, or what they say it does up there, it would take 5.5 hours for that light to go. Pluto, 5.5 hours. And if you think that is even half logical or possible, then they've already gotten to you. So this is most definitely the one that they don't want you to see, because it proves beyond doubt that the speed of light is absolute. There is no doubt. So the speed of the light from the sun, we've got one 5 millimeters in diameter with the Earth distance to scale at 150 million kilometers. It turns out to be 54 centimeters because there are 108 sun diameters in between Earth and the sun. The sun's light and all of the stars in the night sky, they radiate their light at absolute speed. Then, is there a speed? From here to Pluto, let's say. If somebody was on planet Earth with a beeper, and somebody was on Pluto with a beeper, and they said, right, beep when you see the sun. And they were both like this, and the sun turned on, bang! There would be no difference between the thumbs going down because it's that fast, right? It's like our eyesight. Almost a state of mind? I don't know, but it is not trickling along at 299,792 kilometers per second. This proves it. The implications? You tell me. Relativity, the age of the universe, all of it. Things taught, physics, 299,792 kilometers per second. Really? I do not think so. This is the one they don't want you to see. Keep hold of it, record it. There's never going to be a copyright on this. It's not about that. This proves that the speed of light from the sun is absolute. Alright peeps. See you later. That's a wrap, isn't it?